Welcome back, everybody. We're going to be taking a look at Section 7.2, the central limit theorem for sums. So the central limit theorem for sums says if we repeatedly draw samples of a certain size and calculate the sum of each sample, now yesterday we did the mean of each sample, today we're working on sums of the samples, the goal or the idea of the central limit theorem is that they tend to follow a normal distribution regardless of the distribution of our random variable x. So the central limit theorem does assume two things. One, it assumes that we know the mean of x, so we're going to say mu of x, and we're going to say number two, the thing that we assume we know is the standard deviation of x, or sigma x. So by the central limit theorem, CLT for short, we have the variable sigma s. Remember, sigma stands for the sum, tends to be normally distributed. So let's see here. So the sum here is going to take on a normal distribution, and now we need the mean of our normal distribution and the standard deviation of our normal distribution. So what we're going to do for the sums here is we're going to say it's n times mu sub x and then the square root of n times sigma x. So what we're saying overall is that if I have the sigma, or excuse me, the mu of sigma x, so the average of the sums is going to be n times mu sub x, and the sigma for the sums is going to be the square root of n times sigma x. These are items that, again, we do not have to memorize. Make sure you write those in your notes for the formulas. That way you can use these later on when we get to tests and quizzes and homeworks and those sorts of things. So let's do a quick example here. An unknown distribution has a mean of 90 and a standard deviation of 15. A sample size of 80 is drawn randomly from the population. So we have here, if we have the mean is 90, that means mu sub x is 90. Our standard deviation is 15. So we got standard deviation of x is now 15, and the sample size of 80, so n equals 80. So letter A, find the probability that the sum of the 80 values, the total of the 80 values, is more than 7,500. So since we're doing a sum, and we've got a decent size here, we can go ahead and say that the central limit theorem does apply. So we'll say by central limit theorem, let's see here, so we're going to need mu of the sum here, so the average of the sum, and back up here in our definition, it's going to be n times mu sub x. So n is 80. So let's do it this way. N times, whoops, wrong button here. N times mu sub x, and that was the same as 80 multiplied by 90. So that's 7,200. Then we're also going to need sigma. So sigma of the sum of the x's. So we got two sigmas here. We got a lowercase and an uppercase. And what did we say that was going to be? That's going to be the square root of n. The square root of n times sigma. Now my sigma, unfortunately, looks a little bit like a square root up at the top there, but it's sigma of x. So let's see. So we want the square root of n. So we want the square root of 80 multiplied by 15. And I'm going to just leave that as 15 times the square root of 80. As far as our value. So on letter A, it does say that we want to know the probability is more than 7,500. So our probability statement is going to see what's the probability that these sums of the x's are more than 7,500. If we take a look at the graph, again, as we take a look through here, our average was 7,200. We want to be out here at 7,500. We want to be more than that. So this is the area that we're trying to find. So as we take a look at that, we're going to want to be in our calculator. So we're going to say this is the normal. That's going to be the normal CDF. Our left side is 7,500. Our right side is going to be 1EE99. Then our sigma, or our mu rather, is going to be 7,200. And our standard deviation will be 15 times the square root of 80. So I can enter all that into the calculator, and then we can figure out, well, what in the world does that end up becoming? And so let me go ahead and pull my calculator up in through here. There it is. Let's do these and see where we are looking. This one. There we go. So we're going to do the variables. Normal CDF is number 2. And so let's see, what do we have up in here? Oops, that's the wrong file. Let's find that again. Where was that file? Here it is. This is the one I want. Technology is really nice at times when you're a little more familiar with it. I'm not as familiar with this software recording from home, but we'll make the best of it. So this is 7,500 lower bound. Then we have, 1E99. $7,200, and I'm going to have 15 times the square root of 80, so I'm just going to go ahead and type that in, 15 times square root 80. And we get a value of 0.01267, so not a very high value overall in this case. Let's see, so that's, so back up in through here, this is going to become 0.0, well, let's take it to 2 decimal places, so 0.01. So not a very high probability overall in this case, as far as ending up with our sums being more than 7,500. Okay. Let's take another look here at another question. So it's on part B. Find the sum that is 1.5 standard deviations above the mean of the sums. So we got 1.5 standard deviations above the mean. So let's see. So we want whatever our mean is. So let's do mu of the sum here plus 2 standard deviations. So we want 2 times the standard deviations of sigma x. So we then want our 7,200 plus that's 1.5, not 2. Let's go back and replace this. 1.5 multiplied of the standard deviation. The standard deviation was 15 times the square root 80. So we can plug that just into our calculator again. 7,200 times 1.5. Excuse me, 7,200 plus rather 1.5 times times 15 times square root, wrong button again, times square root 80. I mean, that was 7,401. So 7,401 is our approximate value if we want this, the value that is 1.5 standard deviations from the mean. Okay. All right, well, let's take a look at example 7.6. In a recent study reported October 29th on the Flurry blog, the mean age of tablet users is 34-year-olds. We looked at one like this similar in section 1. Suppose the standard deviation is 15 years and the sample size is 50. What are the mean and standard deviation for the sum of the ages of tablet users, and what is the distribution? So as we take a look at that one, we're going to go ahead and take a look, and we want the sums here. So on letter A, let's see here, we start with our normal mean. So the mean, they said, was 34, and our standard deviation of x, so that is 15, and n is going to be 50. So the mu of sigma x is going to be 50 multiplied by 34. And so 50 times 34 is going to end up being, 1,700. So basically half of 34 is 17. Add the zeros in there, so we got 1,700. And our sigma of E sub x, as far as our sum, that's going to be n, excuse me, square root of n, sorry about that. So the square root of n, so square root of 50, times my sigma of x. And again, I'm just going to leave that as square root of 50 times 15 and let it go at that. And what is our distribution? That's the question that's asked in here. So by the central limit theorem, the sum of these x's will become normally distributed, and we will have our parameters of 1,700 and then 15 square root 50. That will end up being our value as far as what we have in that case. Let's take a look at letter B. When we find the probability the sum of the ages is between 1,500 and 1,800. Okay, so let's see here. So we've got 1,700 is our center. We want to be between 1,500 and 1,800. This is what we're trying to find in through here. So we want the probability. Whoops, too many zeros in there. Probability that the sum of the x's is in this range. So that's going to be a calculation into our normal distribution again. So I'm going to say normal CDF. And let's see, our left side 1,500, right side 1,800. Then we fill in our mu and our sigma. So we've got 1,700 and then 15 times the square root of 50. So you can pause a moment, plug that into the calculator. I think that one I already have calculated. I saw that in my some notes over here. So that is going to be 0.8. All right, last part C there. Okay, looks like I ran out of space just a little bit. So to give myself a little bit more room, using a different software on this one. So let's take a look here. So all right, so part C, find the 80th percentile for the sum of the 50 ages. Okay, so we want these ages here. We want some value k, where this region in here is the 80th percentile, so 0.80. So that is going to be the inverse normal. Okay, so inverse norm, and we're going to want 0.80. Let's take a look at what else we need in the wizard. Like I said, I don't memorize these things either. I tell you to go ahead and push buttons and then take a look at what it is. I'm doing the exact same thing. So inverse normal. And we have the area, and then mu and sigma. Okay, so we want our area to be 0.8. And our mu in this case was 1,700. And our sigma was 15 times square root 50. And so the 80th percentile is going to be at 1,789. So that's going to go 1,789, and this was our 1,700, and then 15 square root 50. Okay. So we've got it. That's our k value. So 80% of our values are, the sums are 1,789 or lower. Last example here, let's take a look. The mean number of minutes for app engagement by a total user or by a tablet user is 8.2 minutes. Suppose the standard deviation is 1 minute. Take a sample size of 70. All right. So as we look at these, so we've got the mean number is 8.2. So mu of x is 8.2. Standard deviation of x is 1. and we got a sample size of 70. So those are the values that we're going to end up using. So letter A, what are the mean and standard deviations for the sums? So the mean of mu sub x is, again, it's going to be the number of items in our sample multiplied by our mean, which is 8.2. And I'm just going to pull my calculator over to the side here real quick. So 70 times 8.2 is 574. And our sigma of our sums here is the square root of 70 multiplied by 1. Oh, that's going to be nice and simple. That's just going to be square root 70. So part B, find the 95th percentile for the sum of the sample and interpret this in a complete section. So 95th percentile, so we're looking for this value here, and we want this area to be 0.95. So like our last question, we got the inverse normal, and we're going to have 0.95 as our area, and then our sigma here, or our mu rather, I keep calling that sigma, sorry about that. Our mu is 574, and our standard deviation is square root 70. So we want to go ahead and plug that into our calculator. So I'm going to inverse norm again. So hopefully you are doing this as I do it as well and figuring these things out. So 0.95. What was our sigma here? This is the part I don't remember. 574 and square root 70. So 574 square root 70. Let's delete these other items. And we get 587.8. So 587.8. So that's going to be our 95th percentile. So what are we saying about that then? If it asks to interpret the sentence in a complete, or interpret the value in a complete sentence, so we would say here, this is the tablet uses the mean number of minutes. So the average number of minutes for 70 tablet users is going to be 587.8 minutes. 95% of the users are going to use 587.8 minutes or less would be our item that we're looking at. Find the probability that the sample is at least 10 hours. Here's going to be an interesting item for us. Let's take a look at this real quick. 10 hours when everything else was given in minutes. So I've got minutes there, minutes there. So this 10 hours I'm going to have to convert to minutes. So 10 hours is going to be 10 hours times 60 minutes in an hour. So that's going to be 600 minutes overall. So we have the probability that the sum is at least 600 minutes. So here's our average. Our average was, what do we say, 574 back over here. And we want our average to be more than 600. So that's what we're taking a look at. So that's going to be, again, the normal CDF, and our low value is 600. Our high value is going to be infinity, and we've got our mean and standard deviation as 574 and square root 70. So let's see here. So that's going to be our normal CDF again. So let me find that. Let's see, we got 600. E99, then we got 574, and we've got square root 70. And it looks like I've got an error message on here. Let's see, some normal PDF, our X value. Let's see, so I've got 600, 1e99, 574, square root 70. All right, so we'll just start over. It looks like something it did not like. So lower bound. I wonder if I click, I think I might have accidentally clicked the PDF. Okay, yep, big fingers there. So 600, 1e99, 574, and square root 70. Yeah, there we go. All right, so the probability of the sum is at least 10 hours, so 600 is going to be 0.0009. So that means that is going to be quite tiny overall. Yeah, so that probability is going to be almost non-existent to have the number of minutes for these 70 users. There's some of their minutes to be over 600. Okay, well, a little rough start as far as the video there. Hopefully that all makes some good sense. Ask each other for some assistance. Start working on the homework. And if you have a question, please feel free to email me, and I'll get back with you and take a look at things as they progress. All right, thank you, and have a good day.